So for 3.7, we're on unit 3.7. And this is factor quantities. Right? Quantities just means like a whole group of things in parentheses, basically. So just as a very small review, for number 1, I would like you to factor completely 100 y squared minus z squared. 100 y squared minus z squared. 100 y squared minus z squared. What kind of factoring is that?
Difference of squares.
Difference of squares, okay? So hopefully we remember we would just do 2 sets of parentheses. One gets a plus, one gets a minus. What does 100y squared break into? 10y and 10y. And what does z squared break into? Z and z. Okay, easy enough, right? Difference of squares. What we're going to work on first is essentially the same thing as difference of squares. It's just going to look a little bit different. So for number 2, again, I would like you to factor completely quantity, so in parentheses, a plus b quantity squares. A plus b quantity squared minus m squared. A plus b quantity squared, so that means in parentheses squared, minus b squared. B squared, m squared, sorry. Write that down. A plus b squared minus m squared. Now, this looks confusing if we just look at it like this. So what we're going to do is, instead of writing it like this, we are actually going to substitute. Okay? I would like you to substitute, instead of writing a plus b, I would like you to substitute that for a q. Okay, I'm going to use a q because q represents a quantity to me. You really could use any letter you'd like to. I would definitely not recommend an x because a lot of these problems have x's in there to begin with. But if we replace something, this would become q squared minus m squared. Now, this just looks a lot easier. So this is really a brain thing, okay? It's the same problem. But for some reason, when I write q squared minus m squared, everybody thinks it's easier. It's the same problem, okay? But it becomes easier because it looks better. If you broke this down, what would that break into as far as parentheses?
Q plus m, q minus m.
You still break down, put a plus and a minus. Q squared would still break down to q and q. M squared still breaks down to m and m.
But it's the same thing.
Then you have to put it back. Okay, that's why I use a q, because we never use q's in math hardly. So hopefully that looks strange to you. Like, this does not belong. You have to put something back. That's also why I'm using a different color, so that I'm realizing, hey, this is not done yet until you put it back. So from here, you need to put back what I took out. I took out a parentheses a plus b plus m and a plus b minus m. Now, I fully understand that most of you are not probably going to substitute this in parentheses. Most of the time, that's okay, because it won't change anything. But sometimes we will have to distribute for this first one, so I would prefer if you would just leave the parentheses, and then in the next step, you can get rid of them. Okay, so this becomes a plus b plus m times a plus b minus m. Notice, what was in the parentheses did not change. Okay, it's not like one is positive, one becomes negative. The a plus b stays exactly the same. This is your answer. Question?
If we put down an answer with parentheses, will it be marked wrong?
It depends. Sometimes if you have to distribute, it would be marked wrong.
Okay.
It depends on the problem.
In the case of this,
you will never see a multiple choice question written with the parentheses still in there.
Okay.
We'll say that. So it's not necessarily wrong, but it's kind of like not simplified enough, so it's a little bit lazy. Okay, how about something like 9 quantity x minus y squared minus 49. 9 quantity x minus y squared minus 49. Yes. Is there a GCF here? No, 9 doesn't go into both 9 and 49. But that's a good thought. Some of you thought, hey, GCF, there's a number in front. That would be great, and yes, you should look for the GCF. This one, unfortunately, does not have one, though. So, I'm going to substitute, okay? You don't have to write the word substitute each time, but I would definitely, somewhere in your work, show that, okay, x minus y, I'm going to substitute that in for a q, or whatever letter you choose. So, this is going to become 9q squared minus 49. What kind of factoring is that now? Difference of squares. Hopefully it's easier once we substitute things. It just tricks your mind into thinking that it's easier, and it is. Then, 1 gets a positive, 1 gets a negative. What does 9q squared break into?
3q.
3q and another 3q. What does 49 break into? 7 and 7. Now, this is why it's important that whenever you plug things back in, you do so in parentheses. This is actually 3 times x minus y plus 7. If you don't write it in parentheses, this is what happens. See the difference there?
Yeah.
That's a problem. This 3 should go to both the x and the y. If you forget the parentheses, it only goes to the x. So you have to write this in parentheses. Okay, it has to be distributed through everything. You can't just give it to one part. Then your last step, this is not an acceptable answer, by the way. Okay, you cannot leave parentheses inside the parentheses. You do need to distribute that, so that becomes 3x minus 3y plus 7 and 3x minus 3y minus 7. That's the answer that we're looking for there. Questions so far? Good? Okay, let's try another one. Same thing. Number 4, I would like you to factor completely x squared plus 4x plus 4 minus 81c squared. X squared plus 4x plus 4 minus 81c squared. What is wrong with this right now? Is it a quantity right now? No. Could it be 1?
Yeah.
How could it be turned into 1?
By using trinomial. The trinomial method.
You can factor this. Sometimes you have to factor it, okay? What does this break into? What is x plus 4x plus 4? What is that factored?
X plus 2 squared.
X plus 2 and another x plus 2 minus 81c squared. If I rewrote this as x plus 2 quantity squared minus 81c squared, do you see how this turns into one of the problems that I'm doing? Okay. If I replace this, I'm going to replace the x plus 2 with a q. Replace that. Rewrite it. So this would be q squared minus 81c squared. Now it just looks nicer. Like this problem looks like it's going to be a whole lot easier than this big one that I started with. So it's kind of just about rewriting it into a form that is easier to work with, basically. Okay. From here, what kind of factoring can you do? Difference of squares. So q squared breaks down to q and q. 1 positive, 1 negative. 81c squared breaks down to 9c and another 9c. Then replace what we took out. So the q, I'm going to replace it with an x plus 2 plus 9c and an x plus 2 minus 9c. Then there's nothing to distribute for these, so you can drop the inside parentheses, and we're going to end up with x plus 2 plus 9c and x plus 2 minus 9c. Now, sometimes you will be combining like terms in these. Okay, we will get to those in just a minute. So that is completely possible. Okay, that's our answer that we're looking for. X plus 2 plus 9c and x plus 2 minus 9c. Questions on that one? Good? Yes, ma'am.
How come you can't combine like terms for that?
Well, there aren't any like terms. What would you combine? The x and the 2? What does x plus 2 mean? Oh, you mean with these? That would be multiplying. So you're saying why don't you multiply them all together? That's kind of the opposite of what we're doing. So if I multiplied these together, you would actually get this whole thing. We don't want that. Yeah, please do not factor and then multiply again. Okay? Same thing with please don't multiply and then factor again. If you give me the answer that you started out with, but that it takes half a page of work, that's bad. Okay? Please don't do that. Okay, let's try another couple. Okay, now, just as a review for number 5, I would like you to factor completely x squared plus 12x plus 35. X squared plus 12x plus 35. I'm trying to make these quantity problems as simple as possible, okay? This is hopefully, I think, a pretty simple problem. How do you factor this? What multiplies the third, or what would your signs be? Both plus, both minus, or one of each?
Both plus.
Both plus. What multiplies the 35 adds to 12?
5 and 7.
5 and 7. Done, right? Nice and simple. We are going to turn the quantity problems into this type of thing. All the ones that we just did were all basically difference of squares quantity problems. Now we're just going to do quantities, but with trinomials. Okay, but it's the exact same premise, excuse me. For this one, if I give you quantity 3x plus 4y quantity squared, so quantity means in parentheses, plus 2 times quantity 3x plus 4y minus 24. Especially with the trinomials, they just look really complicated here, okay? But they're not. We're totally going to simplify them. So here, I'm going to replace a 3x plus 4y with a q. Okay, let's replace these with a q. Then, it's just going to look a lot easier. So, q squared plus 2q minus 24. Now it just looks like a nice trinomial problem, and it looks a little easier. So what would your signs be? Both plus, both minus, or one of each? Negative at the end means one of each, so one positive, one negative. Okay, the q's will break down. What's going to multiply to negative 24, add to positive 2? What multiplies to 24, adds to 2? 6 and 4. Hopefully we realize the larger one goes with the middle sign, so 6 goes with the plus, 4 goes with the minus. What I will caution you on is do not stop right here, okay? On your test, for sure, there are going to be problems that would say like x plus 6 and x minus 4. That is not the answer here. You can't just arbitrarily put in an x and think you're done. Absolutely not done. To get done, you actually have to plug back in. So I'm going to plug back in the 3x plus 4y plus 6 and the 3x plus 4y minus 4. There's nothing to distribute, so you're going to drop those inside parentheses. So this just becomes 3x plus 4y plus 6 and 3x plus 4y minus 4. That is the answer that we're looking for. Questions? Good. Okay, let's do one more, and then we'll be done. I'm cutting one off your notes. Okay, do one more. I'd like you to factor completely x minus 7 quantity squared minus 13 times x minus 7 plus 36. X minus 7 quantity squared minus 13 times x minus 7 plus 36. So first thing you want to do is replace. So take out the x minus 7 and we're going to replace it with a q. So I'm going to substitute in. That'll become q squared minus 13q plus 36. Then just do normal trinomial factoring. So if you do 2 parentheses, what are your signs going to be? Both plus, both minus, or one of each?
Both minus.
Both subtract. If it's plus at the end, they're both the same as the middle. And what's going to multiply to give you 36? Add to 13.
9 and 4.
9 and 4. Doesn't really matter which one you put first because they're both going to be negative. Then replace these. Okay? Replace this with an x minus 7 minus 4 and an x minus 7 minus 9. What happens here when you drop these parentheses is you're going to get x minus 7 minus 4 and x minus 7 minus 9. What do you actually have to do there? Say it again. Combine the like terms. Okay? When you combine the like terms there, we get x minus 11 and x minus 16. Okay? Totally probably not what you thought would happen at the beginning of this problem. Yes. Question.
So you combine them if they're exactly the same?
If they're like terms, you should combine them, yes. So like these are numbers. Those can be combined. For sure.
Oh, inside the
Huh? Yes. Okay, anyone have questions on how we did that? No. Okay, you do have 16 problems in these. You are doing all of worksheet 7, numbers 1 through 16. Okay, a lot of you guys got